going to be our last lecture from me. And the topic is on system build, implementation, and maintenance. If you think about it, this is like the topic in your course or your course with Simon Villalon for advanced systems implementation. Okay. Um, there's going to be some connection between this lecture and the course that you just had under him. I guess just to put a little bit of differentiation, I'm not really going in depth into perhaps the practices, the nuances of implementing systems. Okay. Um, in fact, that can also sway into discussions on consulting and the like. No, but for our lecture for today, I'm just going to talk about the main elements, the basic elements that's really tackled in this phase. Okay, and uh, and then maybe point out a few things that would be interesting or helpful for you, especially in your line of work, if you find yourselves having to implement a system for your organization. Now, a few definitions. A system build, okay, is the creation of software by programmers involving development, okay, programming, building release versions of the software, and testing by programmers and end users. Writing of documentation and training of people involved may also occur at this stage, okay. Now, when we talk about system build, this is like a catch-all. In fact, this can be used interchangeably with development. So when we talk about development, normally we talk about system build. And sometimes when we deal with development, we are also concerned about software, but we can also include things about hardware as well. So there are a lot of considerations in this stage with respect to development, right? Um, and then during the phase of development, you can, well, it's advisable that you already start writing your documentation, but you don't really have to complete them during this period. Naturally, of course, you'll have to wait until everything is completed. Also, during this period, you can probably do some training already, but the training would have to be very specific. Okay, it could not be the training, let's say, on how key users can use the system. I think it's still early. Um, Also, this would depend on the methodology that you use. Now, in the more traditional sense, if you're doing the typical waterfall, for example, normally these things depend on the methodology that you use. Now, in the more traditional sense, if you're doing the typical waterfall, for example, normally these things get traction towards the end of your entire life cycle. But if you're using a different methodology, for example, agile, specifically, let's say Scrum, you're probably going to do your documentation and even your training as you go through the actual development. Okay? Especially if you're having multiple iterations of development. Okay? But this can happen. But this can happen. Okay? And another definition that we have here is on system implementation. Okay, so after you build the system, now you implement it. Okay, other texts would have this as rollout or deployment. Okay, I mean they can be used interchangeably. So when we talk about system implementation in this context, we're thinking of after you're done creating the system, the software in particular, then you roll it out. Okay, so the transition, the changeover, okay, or cut over. I mean, there are many terms used here. Um, from the old way of doing things to the new way of doing things. Okay, and you also have to consider the preparation. Okay, making sure that the hardware and the network infrastructure are in place. Okay, testing the system as a whole. So you're not only just testing the software, you're testing everything as well. That's also included. Also, considering human issues, will there be resistance to the use of the system? Will people really make use of the system, or will it just mothball into something that's not going to be used frequently. Okay, and of course training other people. So if you've noticed, um, what occurs in both build and implementation phases is the fact that you can have testing that's involved there. You can also have documentation that happens along the way, and even training. So you can see that there could be training activities in both build phase and the implementation phase. Now, just as a quick note, okay. So this is the definition, very simple definition of data migration. So it's really transferring the data from the old system to the new system. Now, if data is going to be added to a database, you call that populating the database. Now, why are we calling out data migration as a standalone topic right now? Okay. Uh, More often than not, people neglect the importance of doing proper data migration. Sometimes, and we've seen this in the past, we've seen a lot of implementation that's really just focused on, not just focused on deploying the software itself, okay, or the software plus the accompanying hardware, okay. But in some cases, they forget what to do with the old data. Now, if you're dealing with a completely fresh new system, meaning nobody is going to change an existing system, I mean, it's completely new, you're not making any upgrades or updates or anything of that sort, perhaps data migration is not an issue. But more often than not, when you are implementing a new system, it is possible that the old way of doing things would be there. So having to consider how you make use of the old data into the new system, that is a very important issue that has to be addressed. Okay. And something that I forgot to mention this at the start is the course is about advanced systems design. Okay, so why are we talking about things about during the build process, the development, the deployment? Why is this even a concern for design? Well, if the design is done very well, you also consider during the design phase the idea on how you actually implement and roll out the system. Okay, so these two topics, systems design and systems implementation, they're not independent of one another. In fact, they will lend their strengths to each other. And it's good for us to appreciate this topic of systems build, implementation, maintenance in light of systems design, because when you do the design properly, or if you've considered even the deployment and the maintenance, even during the design phase, then things can be more convenient for you when you actually reach the stage. For example, you can actually design a system that is easy to maintain. Okay. Now, more often than not, if you want a system that's easy to maintain, then ideally you would like to design a system that will foresee even requirements that is not yet a hard requirement at this stage. Maybe at this stage it's just like a desirable or a nice to have. But if you've already incorporated that in your design early on, then you're not going to wait for the desirable to become a requirement, okay, before you actually incorporate that into your system. Okay? I mean, you can be way ahead of the curve already if you can somewhat predict or anticipate that this desirable now, tomorrow, this will become a hard requirement. Okay, so at least you save time in the maintenance side of things, especially when we're talking about upgrades or patches and the like. Well, you've already avoided that. Okay, so that's one example on how having a very solid or a very exhaustive type of systems design would actually help you in in the systems implementation portion. Okay. Or if you'd like to design a system that, as they say, is future that already requires the latest specifications of your hardware. So when that time comes that we're going to roll out the new system, okay, you won't roll out your system if the specifications are already met, right? So you're not going to wait until the specs will be needed already. So just like what I mentioned earlier, I mean, it may be a desirable now, but if you've really incorporated that as a key feature, as a key component of your design in your system, then you won't have to wait for the desirable to become a requirement, okay, before you actually do actions around it. So of course we're focused on data migration. That's also the same idea. You want to be able to come up with a design wherein data migration can also be facilitated. In fact, data migration is very pertinent as well if you're moving from a manual based process to something that's more automated. For example, paper based forms. I mean, there could be a lot of paper based stuff out there, and perhaps they're not yet encoded in a database. So now you'll have to encode them in a database. So even the consideration of designing a format for your database that allows compatibility with your paper-based forms, okay, that's also a mark of good design. Okay. Now, when we talk about implementation at this stage, right? Of course, quality is something that really crops up. Okay. You definitely want to make sure that your outcome is something that is accepted by all users. Now, it's also important for us to consider quality in this lecture is because it's also important that we think about quality even during the design stage. Okay. Now, there are many types of quality. Okay, one is the software and systems quality. So it should answer a couple of questions, right? It should answer, does it meet the business requirements and does it work reliably? Like, can it do the job required? And will you be able to make sure that this software will not hit into many problems? Okay. Uh, well, primarily it's a software consideration, but later on, when you take a look at quality, you also want to consider other infrastructural elements to it, like hardware, storage, performance. Okay. Now, when we deal with quality, there are a lot of questions that we'd like to ask. I mean, these are some of them. They're not really meant to be exhaustive. Okay. But if you're able to think of these questions even during the design phase, okay, naturally, when you design something, it should be according to the specifications. So you should be able to answer the first question here: does the product work? Okay. Does it crash? Okay. Sometimes it crashes because of some performance constraints, right? You're probably going to expect, let's say, for example, 1,000 concurrent users. Okay, is that something possible with your system? Maybe you've only designed your system to handle at most, let's say, 100. So in that scenario, in that case, you realize that, okay, we can avoid having quality issues in this manner if we've actually thought of the design to factor the possibility of 1,000 concurrent users, or just as to cite an example. Okay, other guide questions here. Does the product function according to specifications? Does the user interface meet product specifications and is it easy to use? Okay, so convenience. Are there any unexplained or undesirable side effects to using the product which may stop other software working? So you take a look at the interconnectivity of your software with other systems that are already working. So ideas of compatibility or being able to interface with other existing systems. Now, sometimes even during the design phase, that can be a very tricky question because maybe the solution that you have in mind is just for this specific system, right? should consider developing the other systems also in tandem. Okay, and that's also a consideration of your system design. Okay, the fact that there is that need for interoperability between your new system and the other older side systems, so to speak. Okay, you have to bear that in mind. I mean, you cannot just ignore the fact that your old system, okay, used to interact with these other systems, and your new system now will just practically ignore it. Okay? I'm not going to deal with that, right? In fact, it's possible also that when you're trying to address the problem, okay, if you recall the very, very first premise of our course is that we want to address a problem, right? So maybe the problem is not exactly that one specific system. Maybe you're supposed to have an integrated way of collecting all of these systems into one. Maybe that's the problem. So, but obviously, that's part of your consideration of quality. Now, if you've made the decision just to update or upgrade one system, which needs to interlock with the other systems, then you have to make sure that the new system eventually will still work with the other systems that the old one was connecting to. Right? Now, in order for us to assess quality, the most fundamental activity here is testing. Okay, so typically testing is pretty much the domain of implementation. So there are many ways to test. There are a lot of considerations to think about. Tools, there are a lot of available tools that are out there for testing. Okay, um, when you're prototyping, okay, testing. The purpose of testing is really to identify missing features. So when you're during the build phase, okay, your idea is to be able to find out whether you've covered all of the specifications that were required. Okay. Now, once that is done, as you are going to roll it out, okay, you also still need to test. But this time, what you test would be the reliability of your system. Will there be many bugs? Will there be none of them? Okay. Because by this stage, the assumption, the premise is that your system is supposed to be able to address all of the functional requirements. Okay. So there shouldn't be any missing issues at this stage when you're about to roll them out. Okay. The only thing here is that you're not really sure whether the system that you've done is actually going to have any other side effects, or will it have issues in terms of scalability. Okay. And that's what you're trying to find out. Okay. Now, some concepts under testing that would be important for you to consider. Well, a test specification, it's a detailed description of the tests that will be performed to test the software, to check the software works correctly. A test plan is a plan describing the type and sequence of testing and who will conduct it. Now, the main lesson here is that testing is not something that is spontaneous or uido or doing things by ear. Okay, rather testing is something that's very deliberate. And even during the design phase, you also need to understand already the types of tests that you are going to encounter when you start to build and implement the system. Okay, so and there are many ways, there are many standards of coming up with your test specification and test plan. In fact, as a discipline, it is something very rigorous. I think there are many standards that are out there as to how you do your test specification in your test plan. Right? As to there are many types of tests, which we will discuss in a while. Now, the V model, I chose the V model aside from the fact that it's available in the book. I think what appeals to me as to using the V model is um, on the left side of your V, these are your typical phases of development. On the right side of your V, this would be your typical phases of tests. Okay, and there are different types of tests depending on what phase you are probably in. Okay, well, not really what you're probably in, but uh, each phase can be tested according to certain tests that are done. For example, for the detailed design, okay, one way test whether you've actually fulfilled your detailed design is if you conduct a unit test, okay, and you pass the unit test. If you want to test whether the overall design is stable enough, okay, it really works across everything else, then you take a look at your system test. You do a system test. Okay. Now, if you want to make sure that things are done according to specifications, okay, according to how the users would have communicated it to you, then you have a UAT, or acceptance test. And then lastly, if you really want to know whether the system was actually something that really works for you, that it was really meant to perform as intended from a business point of view, then you have an implementation review. Okay, I mean, these are different types of tests. And there are many, many types of tests. If you go drill them down one by one, they could be many. I mean, I'll leave it up to you to really, I guess, read up and brush up even some of the different types of specific tests. But uh, the point of this slide is the fact that there are different types of tests to be able to address different types of objectives or needs from the very beginning. Okay. But let's categorize our tests into, well, for now, let's categorize it according to developer tests. So these are tests that are normally done during the development phase when you're still building things. So you can do a module or unit test. You can do system testing. Okay, so if you try to integrate everything, do volume testing or regression testing. Okay, so regression testing, I mean, for those of you, you might know this, is that you want to be able to run scenarios that you can do from the old system. And when you do the same scenarios in the new system, it should give you the same output, right? So the output shouldn't change. Okay. Volume testing, this refers to more of stress testing in some cases. Now, that's how you term it. You want to make sure whether your system can actually handle the volume or the scale that you want it to work on. Okay. And the other types of tests would be end user tests, something that's done by the users themselves. So they participate in the testing activity, and they try things out. So they do functional testing, they do user acceptance testing. These are the typical functional end user tests that you'd encounter in the industry. Uh, Putting tests aside, okay, so now go to another important feature in your implement side is the creation of documents. Okay. I'm not gonna go through each one in depth one by one. Some of them you've already seen in the previous lectures. Like for example, requirement specification, design specification, detailed design, database design. Okay? These are important documents, and it's good that you already start thinking according to how a documentation would look like early on, right? You don't want to wait until everything is done and that's the only time that you'll do the documentation. That's not going to work. Um, that doesn't make sense even. And you might run into that risk that you'll probably not be able to document anything as much as you should. Okay. And there's no problem around it. Sometimes documentation is underrated type of activity. Nobody likes to do documentation because it's tedious. You know, some people they just want to work in IT for the action. Maybe they just like to develop. But they forget that when you develop something, you need to do documentation for various reasons. Maybe there would be issues in the future that would require you to take a look at documentation. There might be things like if you want to improve on certain things, okay, that will also be a potential reason for you why you want to be implement, why you want to do your documentation and the likes. Okay. Now, included in documentation will be things that you will start to think of when you're doing your testing as well. So detailed test plans, test specifications, and other QA documents or quality assurance documents, the picture. Now, after you're done with the implementation, okay, so build, and then implementation, now comes maintenance. So this is not the portion wherein you're done with the cutover. The system has been signed off by everyone. They're okay for use. They're already using it. It's already in production, as we normally say it. Okay, so something is in production. Now you move to maintenance phase. Okay, there are different terms for this. Sometimes, okay, maintenance is one. A more specific term would be warranty, for example. So there's that. It's that prescription period wherein you want to take a look. You're still there. You're not doing anything. You're not doing development work. You're just on standby in case something comes up with the system that you've just rolled off. Okay. Other people would sometimes use the term hypercare. So that's also another term that's also being used. Okay, hypercare typically happens after the cutover. So once you're done with everything and everybody has signed it off, okay, you're still there. Those are those few days just immediately after the cutover that you need to be on standby. You probably need to be alert. Okay. Um, but also in maintenance, I mean, this is also the period where you need to do your post-mortem. Okay, you need to review the project. Okay, you take a look at the problems of the system and problems of how you implement the system. Okay, and there are other changes or additional activities that could happen during this period. For example, coming up with a patch. So it's an interim release of part of an information system that is intended to address deficiencies in a previous release. Sometimes a patch can be very important if there's a risk of disruption to the business. Now, typical patches tend to be security in nature because obviously, if there's a security breach, then that can really cause disruption in your business. Okay, but some other patches would be in relation, let's say, to regulation. Maybe there's a new law that wants everyone to make sure that gets applied or implemented right away. So a patch is normally the easiest route to take. You don't have to wait for the next release, which would probably take you a long time. No, so there are many reasons why you want to go through the patch strategy. Okay, we said about the post-mortem, the post-implementation review. So um, some of us might be thinking that has crossed our minds that these activities, these are like waste of time. Maybe it has crossed our minds. Why do we want to do this? It's already working. Things are doing well. Well, of course, from a best practice point of view, you still want to review something so that for you to learn, so that you don't make the same mistakes perhaps in the future. And also, this gives you an idea on how much work you anticipate to be doing after the cutover. So, and you can only have a good estimate of that if you've actually done a review of what has transpired, right? So, doing a post-mortem. So these are things that you'd expect to look into, okay, during the maintenance phase. Now, are these things something that you want to consider at the design stage? Okay. Well, the thing with maintenance is that you're not going to design during the design phase things related to the patch because these things will only crop up only after you've actually implemented it, right? So, but then the reason why it's also good to consider maintenance even during the design phase is that this gives you an idea on whether you need other parts of your organization to support your client during this period, okay, early on. So you're already anticipating perhaps the sheer amount of resources that would be required during the maintenance phase, and you can already make those assessments at the start of your design phase. Okay, definitely. I mean, that's something that you want to look into. Of course, a lot of these things I mentioned, yeah, they're very pertinent to the systems design phase, but these are things that can also be considered in project management. Okay, and yeah, I mean, we want to make sure that these things are done deliberately. Okay? And maintenance is not just like a dull moment in time, right? It can be converted into something deliberate and planned. Okay? And you can actually negotiate with your client to reduce the amount of maintenance time that is required, right? You can do that, but you can only do that if you've been able to demonstrate good quality all throughout the development and implementation life cycle. And at the same time, you're able to demonstrate your credibility in saying that, the product that we will roll out, the outcome that we will come up with is something that's worthy of of admiration, right? So maintenance need not be just like for the heck of it. Okay, I'll just throw in maintenance because it's there could be problems. Yeah, yeah, you don't know if there could be problems, but if you are able to control the amount of time that you'll spend in maintenance, that's actually cheaper for you. Remember, when you're doing maintenance, you're practically doing nothing. So it does represent opportunity costs, right? You can probably ask that person to do something else already. And yet, because it's maintenance, you have to stay with maintenance for a while. Okay? So even during the design phase, it's also good to understand and appreciate how much maintenance are you willing to implement, okay, or to ensure on the side of the client. Okay. Now we're on our last topic on change management. So when we're building the system, we're rolling it out, okay, and we're already moving into maintenance mode. Um, Change management is actually a very key activity during this period. Okay. Of course, not yet at the build, because for build, you're actually building or developing something that's based on a change requirement. Okay. Normally, that would have been enshrined in your requirement specification for major releases, or it could be just on the change specifications. I mean, for your patches and the like, for your hot fixes. I mean, your change management can be less rigorous. Okay. Uh, and we're going to talk about very briefly on the three levels of change management. So obviously there's software change management, the typical things that you've learned in development. There's also a system change management or information system change management. Okay. And the third level, which some of you would have realized is by now, is the organizational change management, the so-called non-technical side of things. Now, there's this temptation to think that just because we're IT people, we just stick with the technical and we forget about the non-technical, like having to manage culture or getting the buy-in of people. No, you have to understand that that is something that's included when you're implementing systems. When you're doing rollouts, you need to consider the changes that would affect people on how they do things whenever a new system is going to be introduced, right? So there, and that's going to be helpful even during your design phase if you know the amount or the extent of organizational change management that's going to be required. Okay. Now let's talk about software change management. So there are, well, the idea of software change management is that there are multiple releases. Okay, and it's how you package or brand or label those releases that will really dictate as to how far you are in the development stage, right? So an alpha release is known as the earliest release, but because it's the earliest release, you do expect to be the buggiest of all the releases. Okay? Now, a beta release is done after you fixed the earlier releases. You can have multiple beta releases. But once you've fixed everything to the best of your abilities and within the time constraints, you finally come up with what is known as the gold release, okay, or your final release. And, and in principle, the gold release should be like your flawless version of all of your releases. Now, a question comes up: how much or how many releases can we do, or how many releases should we be doing? Three, based on this list. Do we do more? Do we do less? Okay. There's no hard and fast rule on the number of releases that you should be doing, right? Definitely, you need to have an alpha release. Okay? You have to come up with something, right? Even if it's just a sketchy draft, you need to have some draft. You need some place to start. Definitely, you want to have a gold release, a release that is clean, removed of all imperfections, okay, to the best of your ability. Okay, you have that. Now, would you want to have a better release? Okay. In some cases, if it's a too simple a system, probably you can skip this. But if it's a very, very complex system, you'll probably need to have more than one beta release. Okay. So, but again, it really depends on the scope of the work that you're doing. Now, when we talk about the information systems change management, okay, now we will think about um, okay, and then this picture will actually give us a good insight, okay, on the different types of rollouts, okay, or implementations, okay. The first one, so there are four of them. The first one is a direct cutover. Okay, you have your old system. After a certain date, known as the live date, you now have to use the new system. It's like a cold turkey or a big bang type of approach, right? And this is perhaps the old way of doing this. It's simple enough. You have a specific date. Okay, after this specific date, we start implementing the new system, and the old system you can forget about. This would probably work nowadays if your system is not very complicated, right? Okay. But it's very rare that you see a direct cutover. Now, what's a different method for cutting over? Well, you have parallel running. In some cases, you call this the dual maintenance approach. So there is going to be an overlap between the old system and the new system. So slowly, people will start using the new system. In fact, not slowly. People can already start using the new system, but the old system will still be there. It's just turned on in case there are certain things that need to be addressed. Okay. And you can have something run in parallel. Now, after a certain period of time, you can make the declaration or the announcement that you will kill the old system, you'll sunset the old system. Okay? But during that period, you will have two systems that are actually simultaneously running, okay, in a dual maintenance format. Now, that's a little bit of a hassle because you have to make sure that whatever change you do to one, you also apply to the other. So if you input the data in the old system, you make sure that you also input the same data in the new system. Okay? For as long as you're doing things in parallel. Now, another approach would be the phased approach. So by phased approach, this pertains to the modules or the features, right? For example, your system boasts of 10 features. A phased approach would be that I do feature A first, and then feature B, and then feature C, all the way until all the modules are implemented. Okay. Now, when all of the features are implemented, that's the time that you can sunset your old system. But for as long as you keep on building your feature after feature after feature for your new system, you'd still want to maintain your old system, right? So that's a phased approach. Okay. And the last method for rollout would be doing a pilot. Okay. And in this case, instead of phasing out your features, you're actually phasing out your users. So it's possible that you do your system, you implement your system with a certain group of people first. They're already using it. And then later on, you include other people. Okay. Then you include another set of people, another set of teams. Okay, until everyone is already using it. When everybody's now already using the new system, then you can sunset the old system. Okay. So that's the difference between phased and pilot. It may still look staggered as far as optics are concerned, but they're different because phased approach refers to the phasing of the features of the system, whereas a pilot approach refers to the stakeholders of the system or the key users of the system. And lastly, we go to organizational change management. So for me, this is a more intriguing part because this is not technical, but if you don't really do well in this portion, then no matter how good the system is, no matter how sassy, how elegant it looks like, if this component is not really done very well, you can actually end up botching up the entire thing. Okay. And when we talk about organizational change management, one thing that really is at the heart of this type of change is the fact that you're making changes in your business processes. So there are different types of changes or categories in organizational change management, right? So way of looking at it is BPR, or business process re-engineering. So it's identifying new ways of carrying out business operations, often enabled by IT capabilities. You can see BPR in cases wherein the old way of doing things is not IT enabled, and the new way of doing things would be IT enabled now. That's back in the old days. But I think there are still companies that may have systems that are still done manually, and then you introduce the use of IT, you probably need to do BPR, okay, or business process re-engineering. Now, a more subtle way, a less complex way of doing BPR is what is known as business process improvement. So you try to optimize, tweak existing processes, okay, which are typically coupled with enhancements in IT. So it's possible that your business process already has some IT running already, and then okay, we look at we look at ways on how we can still improve the process and improve IT at the same time. The scale of the improvement is not as big as BPR, but it still affects your business process. Okay? And all these things, they actually form part of business process management. So it's another field. Okay. In this case, it's both a philosophy and a collection of supporting technologies for process change. Okay, and when we're trying to achieve organizational change, okay, so these are the things that we have to consider. Okay, organizational culture. Okay, uh, there's a whole wide field in literature, okay, in the literature that talks about organizational culture and its impact to growth and development, and especially in the relation to IP, right? Uh, but you still have to consider culture. I mean, sometimes when people design systems, yeah, maybe part of culture consideration would be in the how you implement UI or UX, user experience. But that's not enough. I mean, when you start to roll it off and expect people to use it, it's also important that you know, will they adopt to it? Will they want to use it? Okay. Uh, And then part of it, okay, which is the second point here, is the user involvement. How involved would be the users be? Or is this just going to be a massive imposition by management? Okay, I don't care how you feel, you users. This is the new system we want to implement, use it. Is it something like that? Or is it something that it's a little bit more participative or democratic, if you want to call it that way, where the users can shape how the change is actually going to take effect? Okay, will users have a different job description already when you start implementing those changes in the organization? Also, part of it would be resistance to change. You also consider these things. Sometimes when people get used to doing things, they've already built a habit with respect to workarounds. So from their perspective, it might be efficient to them, but from a third party point of view, because they're doing so many workarounds, it's not really the most optimal approach to whatever it is that they're doing. So do expect that there will be resistance to change. Okay, and a lot of this is really psychological more than anything, cognitive. Okay, there's nothing technical about it. If you ask me, what's the technical reason for people not wanting to change right away? Well, there's nothing technical there. Okay, probably they're just resistant to change because, well, some of them don't like to be trained again. Some of them feel that nothing's broken, everything's working fine, even if you're doing workarounds left and right. Okay. Or maybe it's some non-objective reason. Maybe they just don't like the team who's developing it. I've seen organizations that really put up a huge resistance to change because the ones who are implementing the systems, they don't like these people. Okay? Some of them would say these are very arrogant, they don't listen to us. That can happen. Okay, and that can derail any development project that we have. So it's important that we also consider resistance to change. And lastly, training. No? Because you're introducing a new system, so in principle, not everyone is used to the idea of the system. Okay, it's something new, no precedent. Maybe there would be some similarities in look and feel, okay, but that's not going to be obvious to such people, okay, not unless you actually tell them what those changes are or how the new system is actually more beneficial compared to the older system. And for that, you actually need to conduct training. Okay. And for that, that ends our lecture on system build, implementation, and maintenance. I'd like to open the floor for questions if there are any. Okay. Okay.